Welcome to AMS Weather Band's latest webinar, Towards the Perfect Weather Warning, with Brian Golding and moderated by Jenny Sun. As always, before we begin, I would like to address some of the guidelines for our webinar today. First of all, if you have any questions during the webinar, please feel free to put it in the little Q&A button option on the bottom of your screen. Make sure that all your questions go there. Anything put in the chat might not be addressed, so you want to make sure that that goes in the proper spot. We also will have some specific time for questions from the audience after the presentation, or during the presentation, depending upon the flow of the event. Now I'd like to introduce today's moderator. So Jenny Sun is a senior scientist at the National Center for Atmospheric Research and an AMS fellow. Her extensive expertise and interest focus on mesoscale data assimilation, high-impact weather prediction and predictability, convective scale dynamics, and ensemble prediction. She received her PhD from the University of Oklahoma in 1992 and has since dedicated her career to NCAR. Dr. Sun has more than 30 years of experience in mesoscale data assimilation and convective weather forecasting. She is recognized as a leader in radar data assimilation for nowcasting and high-impact weather applications. Dr. Sun has served in several WMO, WWRP committees, including the HIWeather Steering Group. And with that being said, Jenny, the floor is yours.
Thank you, Gideon. I'm honored to be the moderator for today's discussion, Brian Golding. Of knowing Brian for about 20 years. In the recent 10 years, I had the opportunity to work closely with Brian while serving in the WMO's high-impact weather research project, where Brian has been the co-chair, and I was the task team lead for the HIWeather forecasting team. Through this collaboration, Brian left a lasting impression on me with his extensive expertise in Earth, his knowledge in spectrum, ranging from weather to climate and from observations to numerical modeling. In recent years, he has made great contributions toward bridging the gap between physical sciences and social sciences in the context of hazard warning. In addition to his scientific excellence, Brian's exceptional demeanor also made a strong impression. He set an example treating everyone with respect, especially in his role as a leader of a diverse international team. So without further more delay, I'm now pass the floor to Brian, allowing him to provide us with a more comprehensive insight into his journey that led him to the study towards perfect weather warning. So, Brian, it's yours.
Thank you, Jenny. It's great to be here, and I hope everyone can hear me clearly. So, yeah, my journey started back in the 1960s. I was one of those teenagers who had a weather station in the back garden, and that really fired my interest. But the 1960s were also a great time for international meteorology. In fact, there's never been a time quite like it. In the world community, there were three really enormous groundbreaking projects that set off at that time: the Global Observing System, the Global Telecommunication System, and in research, the Global Atmospheric Research Program. And that was to last until 1980 or thereabouts. And it involved, it was a huge step forward. It was the time when numerical weather prediction was just beginning to become competitive as a source of information with the traditional forecasting methods. So it was a great time, and I joined the UK Met Office in 1973, right at the cusp of when that was happening. So that was really good. In my early career, I did a number of interesting things. I touched on some data assimilation work. I did some ocean wave forecasting. And then I spent some time, just a short period, as a bench forecaster. And that was really formative. I would recommend every research scientist in meteorology who can to spend a little bit of time in the operations room. You just get a feel for what it's all about. I remember there was one particular night, right in the middle of the night, I got a phone call on a radio phone from the middle of the Atlantic, a yacht who was sailing across the Atlantic and was getting a bit fed up with the gales, severe gales, that he'd been encountering for some time. And yeah, I don't think he was actually in danger, but he was worried. And with the synoptic chart in front of me, I could tell him how much longer he had to put up with it, and so on. It was just it just made that difference to my view of what it was all about. So in the 1980s, then I was a modeler. I was leading a team of modelers, putting together an operational mesoscale prediction system, regional, limited area. We ended up at 15 kilometers grid length. It was a bit coarser than we really wanted, but that was a good time. And it sort of the icing on the cake of that was that I then got a 2-year secondment down to Melbourne, the Bureau of Meteorology, where I put the model through its paces on Australian severe weather, and that was pretty exciting. Back in the UK in the 1990s, rewind a bit. So what had happened internationally in that period after GARP? Well, everything sort of moved on towards the climate. So the fact that you could now simulate the global circulation of the atmosphere with some degree of skill came at the time when the first worry about the possibilities of climate change, anthropogenic climate change, came up. And so GARP the follow-on to GARP was the World Climate Research Programme. And that absorbed the research energies in of the World Meteorological Organization, at least, through the 80s and the 90s. So if we come to the late 90s, there was a recognition that we hadn't solved all the problems in forecasting. And so a World Weather Research Programme was formed at that time. Now, at that time, what I was doing was looking at the gaps that between the numerical weather prediction and the actual forecasts that were going out of the door, and trying to facilitate the automation of those in the UK. And we had quite a lot of success. I did led a project on nowcasting, on site-specific forecasting, and a number, and a lot of work on using ensembles. We were getting them at that time from the European Centre. I followed that up by moving on to direct the programme of forecasting research and development in the Met Office, at which point, of course, I ceased to be able to do useful work myself. The first big project of the World Weather Research Programme was THORPEX. So it was back in the mid-latitudes looking at the issues that arose when rapid developments happened, when to try and look at whether we knew enough, or we could know enough about storms in the particularly in the mid-latitudes, although not entirely, in order to capture the really dangerous ones, which had up to that point we were getting really good by that time at the sort of the average storm, but there was clearly much more to do, and THORPEX was very successful. In 2012, I moved to part-time working, and I retired from the position of director. took on a very interesting project in weather and health, which was kept me busy for a couple of years and moved me in a direction that I've been going for some time, which was towards the impacts of the weather, not just looking at the hazard, but looking at the impacts on people. And that was how I came into HIWeather, really. Yeah, it's been quite a journey. I've always sort of been on the cusp of between the physical scientist doing the modeling and the consultant applied meteorologist looking at its application. And it's a really interesting place to be because you have some feeling for the capabilities of the models and the things they can do and the things they can't do from the inside as well as from the results. But at the same time, you're very much involved in the real world difference that meteorologists make, and that's been a fantastic career. So back to you, Jenny. What can I tell you more about?
Thank you, Brian. That's a very interesting introduction and a very fantastic journey indeed. I think, can you tell us more about the background of HIWeather?
Yeah, sure. So I mentioned the Thorpex project, and when that came to an end, the World Weather Research Programme felt that there were 3 areas that needed to be progressed following on from Thorpex. One of them was on polar meteorology. One of them was on subseasonal to seasonal prediction. And that left this third one, which was on high impact weather. Clearly very important to society, and particularly in developing countries. So I was asked in, I suppose it was 2013 probably, to formulate an implementation plan for that project. And we kicked off in 2015, at the beginning of 2015. And the project itself, if I can just share my screen, see if this will work. Ooh. Let's see if this is, yep. No, that's not right. Oh, hang on. It's funny, however many times you do this, you always seem to get it wrong. I always seem to get it wrong. Right, let's try again. There we are. Hopefully you can now see.
Looking good, Brian.
Yeah.
Good. Right. So this was this is the concept of the HIWeather project, and you can see in the middle there 5 silos or pillars it should be. Yeah, that's right. Which were where we started. So we had 5 task teams for the 5 pillars, covering the whole end-to-end process of forecasting and warning. So from the processes in the atmosphere and our understanding of them, forecasting both the weather and the hazard, forecasting the impact through the application of knowledge of vulnerability and risk, and then the communication of the warning, and then evaluation, of course, what so that obviously you need to know how good your processes are. And we did reviews in all of those areas, and then we moved towards bringing them together in a series of cross-cutting projects. So the first of those was the title of tonight's webinar, Towards the Perfect Weather Warning, a book that we produced. Then we also have a project still going on in use of citizen science. we have a project looking at the end-to-end value chain and how you can use the concept of an end-to-end chain to help improve the warnings and forecasts. And more recently, we've been looking at the gaps in the impact-based warnings. We also have an activity going on alongside the Paris 2024 Olympics to look at how the forecasters work in stressful situations. So that's the work we did. We chose a selection of high impact weather events, which are in the red on the in the middle of the circles there, and then we had the interaction with the applications in a variety of areas, and the social scientists were very important there. So as I say, we started in 2015 with a 10-year project, and a lot of the things that we've learned, I think, have been pretty useful, have been picked up by others. Of course, there are a lot of players working in this field, both in the scientific community and also in the humanitarian community. So it's been a good environment to work in. Back to you, Jenny.
Thank you for telling us more about. So here is all about warnings, because warnings are really important. But we like to hear from you, why are warnings important from your perspective?
Yes, well, I used to think they were important because in the same way that forecasts were important. I think I've probably shifted my tune a little bit, but in terms of the scientific landscape today, I think probably the number one is actually climate change adaptation, because warnings are a really cost-effective way of avoiding the worst impacts of severe weather. All the estimates that are done, well, certainly in developed countries, typically come back with a better than 10-to-1 cost-benefit ratio for warnings. And they're relatively quick to implement compared, for instance, with protective measures, engineering measures, that sort of thing. So warnings are a really good way, a really effective way of protecting people from environmental hazards. And that was recognized last March by the Secretary General of the United Nations, Antonio Guterres. And he said this, he said, we must invest equally in adaptation and resilience. That includes the information that allows us to anticipate storms, heat waves, floods, and droughts. Communities and nations need adequate warning and the ability to respond. To that end, I've called for every person on Earth to be protected by early warning systems within 5 years, with the priority to support the most vulnerable first. A really strong push from the UN there. And on the right of this picture is the model of early warnings, the early warning landscape that the World Meteorological Organization uses. It's bigger than just the creation of warnings, which is what I used to think it was all about. But people need to know about what disasters they're subject to and what they might need to do, particularly if they're responsible for other people as well. Then, of course, we need to monitor and forecast. We need to communicate a message that is understandable and relevant. And we need to be ready, and we need to get people to a position where they're ready to respond. And all of this is particularly important when we get conditions that are unprecedented. If people can remember what happened last time, then they're reasonably likely to take action. But when we get weather events which seem to be happening with increasing frequency, as expected in a changing climate, of course, this issue of communication becomes really important, because if people have got nothing to look back to say, yes, this is what's going to happen, I know what to do, it's much more difficult to get people to take action when it's something that is not within their experience. And we have to get a lot better at that, because it's going to happen more often. And time again, we see disasters in which the warnings weren't acted on. And quite often, this is because people simply didn't think that it could happen, or they didn't have a plan of how to respond on the point of the heat of the moment. They didn't know what to do. They sort of froze. And so we really need to be good at this, and much better than we currently are. Back to you.
Right, I really agree with you. Producing a warning is just the first step. How people respond to it, how do we use the right language? That's really the final goal. So thank you for saying that. When we talk about warning, I'm sure one question people's mind is, a warning successful? So we'd like to hear your view on this.
Yes, so I'd love to be able to measure whether a warning is successful. It's at the end of the day, a successful warning is one that reduces the losses of property, business, and services. But of course, it's really difficult to measure losses that have been avoided, and we can measure the losses that still happen. And so, of course, if we look at any disaster situation or a major hazard event, we still see some losses, and we say, the warnings were not good enough because there were still losses. And we actually need a way of estimating what the losses are that have been avoided. But what we can say something about what needs to be part of the warning system in order for it to be successful. So first of all, it has to be action related. So at the end of the chain here that you see on the screen, this is our conceptual model of the warning value chain that we use in the HIWeather project. At the end of the chain, at the right-hand end, is a decision, and that decision should drive everything. If there's no decision to be made, if there's no action to be taken to protect people, then the warning is of little use. And if the information provided doesn't enable that decision to be taken, then it's still of little value. We also need, of course, for the information that's going to inform the decision to be received by the person taking the decision and to be understood. And that means a whole host of issues about communication, which I think we might come to in a minute. But we also require the information that's in the warning to be, in some sense, complete and accurate, because otherwise you've got a misleading warning. And in that sense, if the warning is misleading, then it's the worst possible thing is that it's understood and the decision, appropriate decision is taken. It may even put people in harm's way. So there is a balance. All those areas to the left of the chain here, which are the scientific areas working out what's going to happen, they need to be right, and they need to be as precise and definite as possible. But equally, on the right-hand side, you have to communicate that in such a way that it actually reaches and is understood by the people taking decisions. Yeah, back to you.
So, Brian, are you showing any. Are you sharing us your screen or not?
Yeah. Can you not see it?
I cannot. We cannot see it.
Oh, right. Right. I will re-share. I did not realize that. Okay. Okay.
Yeah, maybe you recap this a little bit. People probably have missed.
Yeah, that would be useful. So in HIWeather, we use this model of the warning value chain, and you can see we tend to think. Well, I tend to think as a meteorologist of starting at the left-hand side with the observation. We do some modeling and create a forecast. We then work out what that means in terms of hazards and impacts. We formulate a warning and we deliver it. And that has to be done seamlessly, reliably, and fast in order to get the maximum impact. But if what we deliver isn't what's needed in order to take an effective decision, an effective protective decision, then all of that's wasted. So in designing our warning system, we have to start at the other end. We have to start with the people taking decisions, including the general public, and the actual decisions that they have to take to act to protect themselves or to protect others. And then we have to work up the chain and say, well, what information is needed, what format is needed in order for that information to reach the end decision maker. And as you see, we represent that as a series of mountains of expertise. But those mountains need to be connected if the information is to reach the end user. And those bridges that connect the individual areas of expertise are absolutely critical to the success of the warning. And that means partnerships between disciplines, partnerships between institutes and organizations, many of whom are absolute experts in their area, and each area has its own language, its own specialist vocabulary, its own outlook on what the point of doing the producing the warning is, and somehow those all have to be work together in partnership if a successful outcome is to be achieved. Yeah, thanks for pointing that out, Jenny. Back to you.
Thank you. So you mentioned communication is so very crucial among other things. You know, it's an important part of the puzzle. Can you elaborate more on how to make a warning well received and understood?
Sure. Yeah. So this is not my personal expertise. We have some great social scientists within HIWeather who are really interested in this problem. So if you put out a warning to a population, there are a number of things that can prevent people from taking action. So the first one is if they didn't receive the warning at all. They may not be in the office. They may not be at home. They may be asleep. We need to use a variety of media to ensure that we reach as many people as possible. And if it's a real emergency, then we may need some particular form of alarm that can, for instance, wake them up. Then the next problem is understanding. Language. We often assume that, well, nearly everybody can understand English, can't they, in our societies? But do they really understand it in the same way that they do their first language? If it comes to an emergency message, is the urgency communicated if it's in their second or third language? Does the warning make sense? Do they understand where they are in relation to the area at risk? Is it too technical? Have we used jargon? It's terribly easy to use jargon without noticing it. If you're reaching into indigenous communities, then there needs to be a certain consistency with their traditional knowledge if they are to take action. And then there's the issue of confidence and uncertainty. If, for instance, you say something is 10% likely, then most people, I think, will assume it's not going to happen, so they don't need to worry. And of course, risk isn't quite like that. Then the question is, do they believe it? Do they trust the source? And the source is really important, particularly in some cultures. And there's a list there on the screen of people who might be the source, and it might not be the weatherman in the government weather service who is the best source for people to believe, depending on the country and the culture. And then the one that so often catches us out, is there an action available for people to take? Is there actually anything they can do? And finally, of course, can they do it? Even if they know what it is, are they physically able? Do they have time? So a whole range of things to consider when we're putting the warning together. Back to you.
Okay. Well, you talk about the warning source. So in this day of there are a lot of influencers, or various people can give this kind of information. So really, it's important to know where to get the right information. But that's a different topic. We don't have time to discuss that today. But it'll be very, yeah. So my last question is how to produce complete and accurate information for warnings.
Yes, so this is back to what the weather services do, or the weather services in partnership with hydrologists, oceanographers, and health professionals and energy professionals, and so on and so on. Here's an example that I'll show, and then I'll come back to a bit more generality. So this is an example from something we do in the Met Office, with warnings of nuclear contamination or chemical contamination. It doesn't really make any difference. So the first thing you need to know is what is it that's been released? What's the concentration? And in the case of a nuclear release, our Office of Nuclear Regulation may be able to provide an estimate, or preferably the actual source location should be able to provide it. Then it comes to the Met Office, and the Met Office use their dispersion model using forecast winds, temperatures, and rainfall to estimate the dispersion. Then it goes to the UK Health Security Agency, who will estimate the dose, for instance, on a 10-year-old child, in this case. And then it goes to the Environment Agency, who set environmental limits on those doses for safety. Now, that's an incredibly contorted process. Trying to do that in real time with most of those agencies only working normal hours, you'd never get round to doing it. So a system has been created in partnership, but it's run on the operational system at the Met Office, 24/7 system, and looked after by an expert meteorologist who has access to the experts in the other institutes if necessary. So first of all, what this emphasizes is that for the information to be complete, it isn't enough to tell people the weather, what the weather will be. You have to tell them what the weather will do. For instance, the hazard, is the hazard heavy rainfall? Is it flooding? Is it wildfire? And so on. Then what will the hazard do? Is it going to kill people? Is it going to disrupt travel? And so on. That means coupled modeling or strings of models linked together with forecaster expertise or expertise in various areas. And this is particularly complicated for compound hazards where you've got multiple hazards coming together. Accuracy is important. People ideally want to know precisely what's going to happen. We know as meteorologists that's not possible. And so you have to be very clear about what the level of likelihood is, what the level of confidence is. And that means using ensemble information. Resolution is critically important because you need to resolve the hazard if you're going to predict it. Even more so if you've got very small scale vulnerable elements and you need to know what the likelihood is of those being affected. And of course, particularly thinking of developing countries, it's really important that the very best guidance available is used. And that means that the local forecasters in a country, whatever the country is, need to be able to access information that we take for granted from multiple world centers, that they're not restricted to perhaps methods that they've developed in isolation. And as we all know, everything in forecasting depends on knowing what's actually happening on observations. Now, observations in meteorology are a well established collaborative track, and we're really lucky with what we've got. When it comes to some of the hazards, and particularly to their impacts, we're not nearly so well off. So observations are a really big issue, and looking to the future, I think citizen science type observations, particularly when we get to impacts, are going to be absolutely critical. So thank you for your questions, Jenny. I think we should open it up to the Q&A now.
Yes. We received a few questions. So the first question is from Katie Plummer. The question is, you say the things you have learned through HIWeather. What are some of
Okay, yes. So particularly in the area of communication, I think the research is growing rapidly. 10 years ago, there were really a rather small number of published papers on how people respond to warnings and what it is about warnings that helps people to take appropriate decisions. And I think some of the research that we've pulled together that's been done in response to HIWeather has filled in that research landscape. It's I don't think it hasn't radically changed views, I don't think, but it's made the if you like, the bedrock from which we're working much more solid and grounded, and it's begun to provide the evidence base for some of the directions in which warnings have been going. For instance, impact-based warnings, risk-based warnings. We now have a better idea of the extent to which they are helpful in people taking the right decisions, the extent to which we might need to move beyond those in some situations. Okay. Okay, I see a
You can also see the Q&A
yes,
section.
yes, I can see them.
Mm.
So it's very difficult to see the research actually, the HIWeather research as such, in a particular storm. Certainly, you can see how the warnings well in the UK, for instance, you can see how the warnings are formulated differently as a result of moving to risk-based, impact-based warnings. That is certainly very, very evident, and there is some evidence in post-event surveys of benefits in terms of people's responses. But it's always very difficult I mean, as somebody who's been brought up on verification schemes for models, looking at verification schemes for social communication is quite an eye-opener. There are no clear answers in the same way as there are sometimes in model verification. Yes, tornado warnings.
Brian, can you?
Sorry.
Oh,
I'm
you're
thinking.
Question, right?
I was.
You read the question.
Yeah, sorry. So I'm thinking that we're being directed towards a question on tornado warnings. In spite of all the advances in technology and improved weather forecasts, tornado warnings sometimes fail to provide people with sufficient time to prepare, resulting in many tornado-related deaths. In my opinion, better education and building codes are the key to closing this gap. But how can we go about doing it? Yes, well, certainly better education. The number of times I've heard reports from tornado events in the US that have resulted in fatalities, when people have said, "Oh, but we thought tornadoes never happen in this part of the city," or words to that effect. And so education is clearly an issue. The knowledge of the hazard, the knowledge of the weather part of it is clearly important. The building codes bit, I think, for tornadoes comes down to the question of there being a safe response, which is one of the key things that I think I brought out in the chain, that at the very end of the communication thing, the question there is, does the person know how to respond? Do they have a response that they can take? And that's critical. It doesn't always, I guess, for tornadoes have to be about having your own shelter, provided there is one within reach, given the warning time. But yes, I mean, I think it's tornadoes are in some ways the acid test of how far we've got. They are a very particular and very particularly dangerous form of high impact weather. So what other questions have we got here? Have we got
let's skip a few Brian, I think
Yeah.
you skipped a few questions, right? You went to the tornado question. That's
Yes. Well, I went to that because the
Mhm.
it seemed to be trying to go there when I went somewhere else.
Yeah, there are two more questions above that. Three more. Maybe two.
Above that, yeah. Okay.
By
So,
Winbury.
have we focused on specific types of weather warnings? Oh no, I think I covered that one, didn't I? How do you overcome issues when the
Yeah,
public
you
thinks
covered that.
they have experienced? Oh, it keeps jumping. Experienced a particular kind of weather event, but they are really underestimating the potential impact. I think that's really a critical one. And
Mhm.
the forecast, if we've got the forecast right, and that's a problem in itself, because really extreme events are, the likelihood is that the uncertainty will be in the direction of less severity. So if you, for instance, take the ensemble mean, you will almost certainly underestimate the 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 uh, the likely event. On the other hand, if you take the ensemble extreme, then the odds of it happening are extremely low and you'll get a lot of false alarms. But even if you've got a perfect forecast, communicating that to people when they haven't experienced it is really, really difficult. I think some of the virtual reality um, uh, material that goes out on US television can be really helpful. It would be interesting to know whether there's any hard evidence for that. Actually, I haven't seen any myself, but it's certainly a way of going. Drawing parallels of some sort is useful. Telling people what the impact is expected to be can be useful. So, for instance, in recent flooding events in Europe, I think the flooding went beyond the case where it went inside buildings and made a mess of them, and it moved from there to demolishing buildings with people inside them and killing them. Now, if you could convey that change, that tipping point, if you like, I think that would be helpful. And then, of course, there's the question, can you actually advise people what to do? Can you advise them that now is the time to evacuate? This isn't an event that you can sit out. You need to evacuate now. And I know that there's the difficulties in getting people to evacuate, but I think there's still things we need to learn there about how people respond. But in general, giving them that extra knowledge does help. Question is how much, of course. The next one about consistency with the knowledge of indigenous communities. That means that climate change poses special risks to indigenous communities because of the never seen it before thing. Well, yes, but I don't think consistency has to be consistency of the information. It's really consistency of the message. So, for instance, if the indigenous forecasting methods refer to some cultural icon, for instance, then communicating the warning in terms of reference to that cultural icon is likely to have greater impact on people than if you put it forward as this is a message from the government. And I think clearly this isn't an area of my expertise, but that's what I'm hearing, that you need to convert the information into the culture of the people receiving it. And I think actually that probably applies not just to Indigenous communities, but to different cultures in general. So the next one down, how could a regional Met Office avoid public miscommunication given that some content farms might be spreading exaggerated information in advance about the impacts? Okay, for example, from the ensemble forecast, just one ensemble member predicts something extreme, while many news headlines would be filled with inaccurate statements which could eventually bring panic. Yes, well, we see a lot of that in the UK. We have a particular newspaper that loves to pick the extreme ensemble member, preferably 2 weeks ahead. Now, the interesting thing about when they do it 2 weeks ahead is that I think it probably has a role in sort of sensitizing people to the real information when it comes later. It's when you have the conflicting information at the short term that I think it can be really dangerous. And to be honest, the regional Met centres have to be very much on the ball about misinformation and get out there and correct it in social media in particular as it happens. And that's a big job. And it's an increasing job, but there doesn't seem to be an alternative. And it's certainly something that in the Met Office in the UK, we spend quite a lot of effort on correcting misinformation. Yeah. Have we run out of questions? There must be some more.
Yeah, we have gone over all questions. So maybe you can give it back to Gideon now.
I reckon so.
Rightio. Well, thank you very much, Brian, and thank you, Jenny, for this event today and for answering the questions of our guests and providing such gripping and informative material for us to consider here. Yeah, that pretty much brings us to the end of our event, everyone. So yes, once more, Brian, Jenny, thank you so much for your time and your effort. And audience, all webinars, remember, will be available to Weatherband members at amsweatherband.org. As always, if you have further questions about this or any of our other events, our other webinars, feel free to discuss on the Weatherband Community Forum. Also, to hear about any upcoming webinars, I'm going to put this on the chat for everyone. Feel free to check out this link. And yes, also just to let you know, we do have another webinar planned for next Tuesday. That one is called Nearing the Peak, September Expectations for the Hurricane Season. So be sure to check that out. And yes, if there's nothing else, Brian, Jenny, again, many thanks.
And, actually, I realized I didn't actually show the link for the book. Oh, have I got time to do that?
Absolutely. Please feel free.
Okay. There we are. So that's our HIWeather book. It covers the whole of the chain, and you've got the DOI there, and you get a direct link if you use the QR code. I'll leave that up for a few seconds for those who want to take it down. Yeah, back to you.
All righty. Well, yes, again, thank you very much, Brian and Jenny. And if there's anybody that needs a little bit more time to get that info. Oh, too late. But yes, thank you. Thank you, everybody, and have an excellent rest of your day or evening. And we will see you next time at AMS Weatherband Webinars. Take care and goodbye.